this case is going, or this disease is progressing and it's going into blast crisis. Secondly, there are other abnormalities that could be detected. And here, example, there is a 6-7 translocation along with the 922. And this is the basic 922 translocation and the TP53 deletion, which shows one red to green pattern. Coming to AML, we have heard the talks earlier, and we have realized by now that genetic abnormalities are well stated now by WHO. So the cytogenetic markers along with molecular markers are very, very important for the diagnosis and for prognostication of many of the myeloid and the lymphoid diseases. And here, if you can see, so all of these translocations, the 821 translocation, which is the RUNX1, RUNX1T1, inversion 16, the PML RARA, which are the good prognostic markers, followed by the poor prognostic cytogenetic markers, are very well given by WHO. And here you can see an image of the 821 translocation. The fish plays a very important role in quick diagnosis of the APML cases that we get. This is to detect the PML RARA rearrangement, which is the 1517, and we can just use fish to detect whether it is positive and negative, and also together we can also detect whether there is any RARA variant. Now this test or this report can be just released within maximum 4 hours in the laboratory by just using this fish technology. So the significance of cytogenetics is to risk stratify. So many of the markers are sole biomarkers for risk stratification in AML, and few of them are, of course, they are favorable ones, which are stated, and these are the partial karyotypes which we have placed, the inversion 16, trisomy 8, and 821, which are good. The poor ones are the inversion 3 or the MECOM EVI, the 6-9 rearrangement, and the 922 in AML. And there are many other complex abnormalities, monosomal karyotypes, which you can see in AML. This is a classic 9-8-21. Yes. This is a karyotype of, this is a complex karyotype which has also the inversion 3, which is there, the deletion 5q and the 7q. So you do not need anything here. Just this karyotype just tells you that this is poor prognosis and the high, so the risk is high. These are the partial karyotypes of KMT2 gene rearrangements. And fish, when you do, we just perform the break apart probe using KMT2A, which tells you that it is rearranged, and that is more than enough, because any KMT2 rearrangement is poor prognosis, and you do not need the partner. But yes, for further characterization, yes, we do need it, and this can be done by conventional karyotyping very well when the metaphases are available. So that there is a 911 translocation, 1119 translocation, which is MLL3, the 611 translocation, and the ELL translocation, the TET1. So these are the common rearrangements which we get, the recurrent rearrangements. These are few fish images which I have placed here, just telling you that just using 6 to 8 probes, which is maximum, you can get a full panel wherein you can, detect purely by cytogenetics whether you are getting the recurrent abnormalities, positive or negative, and then you can place the patient into categories where the doctors can treat them efficiently. And this can be just done within 2 days of the flow report coming up. some of these interesting cases that I've placed here. So this is a case of AML with the monocytic differentiation, and it turned out to be positive by fish for KMT2A rearrangement in 95% cells. Now this, usually they have an idea that fish is just going to give you one partner, that is KMT2A. That is more than enough actually for the clinician to decide his treatment protocol. However, one should also realize there's conventional karyotyping going on simultaneously together, but within a couple of days, we would get the pattern as well after doing it. And here is an example of the 1117 translocation, which is possibly suggestive of the KMT2A MLL T6 rearrangement. Another case here of AML with the monocytic differentiation, and here the fish revealed KMT2A break apart, which is positive, along with many signals of green, which you can see here, and this suggests amplification. So what I want to emphasize here is that just positive and negative is not the answer. We get various patterns in fish, and it's important to interpret and give a result that would be important for the clinician to treat the patient effectively. Secondly, another case here, which is, there was a mutation as well by NGS, and fish was positive for the MUT98 NSD1 here. And usually it is termed as it is a cryptic rearrangement. However, in conventional karyotype, we also got the 511 translocation along with an additional chromosomal abnormality. Anyway, MUT98 NSD1 is a poor prognostic marker. Another example here, the fish, the panel that we have of 6 to 8 markers was totally negative, right? And what we would expect conventional karyotype to be negative, right? But here, conventional karyotype proved to be very important because we could, detect a 1621 translocation, which is suggestive of a first one ERG rearrangement. Now, this is again a rare recurrent rearrangement, which could be very easily detected by conventional karyotyping. Another example here, fish revealed. So again, I would like to emphasize this is just not about positive and negative. When you're talking about fish, what kind of signal pattern you get, you have to interpret it effectively and efficiently and understand what does it mean, what does it reveal. So there was a fish which was negative. Apart from the negative, the entire panel negative, there was just 3 copies of RUNX1 when we use the RUNX1 T1 probe. Now, what does this suggest? Either it is a trisomy 21, either there is a structural rearrangement involving 21q, right? So what it was, we were keen, so we did a metaphase fish and we did even conventional. So there was a RUNX rearrangement. Now, so there was a 1621 rearrangement, and we were sure that it was the RUNX translocation or rearrangement. Very, very crucial, because this is again puts the patient into poor prognosis. Another case here, which reveals the fish was deletion 5q. The pattern was 1 red, 1 green, 2 aqua, which is a deletion pattern. The 7q chromosomal region is deleted. However, when we did conventional, okay, which is another couple of days down, we realized that we were not getting the chromosome 7 at all. Then what is it? Like, why did fish give me this 2 aqua, which is a centromere, which suggests there is 2 chromosome 7, right? So when we did it, we realized there is a small speck everywhere in a karyotype, and this obviously would not even mean a marker. Actually, it is just a speck, or it doesn't even fall into a minute. But we realized there's something wrong. Everywhere there is this minute which is there, and then we did a metaphase fish, and we confirmed that the aqua signal was on that dot. So yes, it is a deletion. Only the centromeric part of chromosome 7 was there. But anyways, it was poor prognosis. We are aware that or we should be aware that monosomal karyotype and complex karyotype in AML is adverse prognosis, and it's very important to detect these. And FISH does give you an indication that it is complex or monosomal, but a karyotype will help you get the entire picture, the entire genome, and looking at all the chromosomes, we could categorize those cases. For example, this is a monosomal karyotype where there would be one monosomy, minimum of one monosomy, along with the structural rearrangement, which is a monosomy 7 here, along with a 2-2 translocation. This is a complex karyotype. Again, you can see the nomenclature which is placed, the n number of rearrangements, and this further can be characterized by understanding which region rearrangements could be there, and we could also find out the genes responsible or important genes which wherein we could know that anyway this is poor. So further testing need not be done at all. Cytogenetic again helps to determine the disease status and also the evolution. There was this one case of AML where at diagnosis, it was showing a trisomy of 4 along with the 821, but this was not the regular 821 translocation. There was an extra derivative chromosome 21. So there is something extra, like how we get an extra Philadelphia. So here we also got an extra derivative 21 because of the 821 translocation. And this was at diagnosis. Once it was when it came for follow-up, it was negative. But the second follow-up after 10 months revealed an additional chromosomal abnormality, which was a 212 translocation. And we just happened to do FISH, and we realized there is an ETV6 rearrangement, which again suggests it's poor. And I believe this patient succumbed to this disease. There are some important biology that happens in cancer, especially when you talk about chromosomal breakage. You're talking about many DNAs breaking up and rejoining, and there are some parts that we see as are microchromosomes, and especially these are the marker chromosomes, the double minutes, the episomes. So all of these are placed under the micro chromosomes, and lot of research is happening in this sector, wherein they are trying to understand what is the science behind having these marker chromosomes in cancer patients. And it's not only in hematolymphoid, but many other cancers as well. So we place marker chromosomes, especially when we do not understand the from which part of a chromosome it is. And of course here it is along with the 911 translocation, which is poor prognosis. Minutes, again, much smaller. I had termed it as minute. However, once I did a metaphase FISH to check whether it's any part of 20, it turned out to be a part of 20. But however, by karyotype nomenclature, I had to put it as minute. And there are double minutes. In complex karyotypes, you will see that you will get n number of these small fragments, and these are the double minutes that you can see. And you can see the karyotype, which is really complex, and you need not do any other test further. Coming to MDS, we have standard tests already, markers already recommended by the IPSSR, and we all know that they are characterized into the prognostic subgroups, and the important poor prognostic markers have to be detected. And this is a small panel for MDS that we have, which is the detecting monosomy or deletion of 7 and 5 chromosome, along with the trisomy 8 and deletion 20. And when you do a karyotype, you also detect the sex chromosome, deletions, loss. Coming to CLL, we have again a panel. FISH efficiently detects the CNVs, and which are usually the deletions in CLL. And what I would want to say is just a panel of 6 markers, and you know where you need to place the patient. And these are some of the images, FISH images, right? Coming to lymphoma, here cytogenetics, especially FISH, plays a very, very crucial role, especially for, where the cases are still doubtful, or whether there is a differential diagnosis, or there is some confusion where it is what kind of lymphoma. We just need to have a couple of markers here, and it's very clear that if at all you get an 11-14 translocation, it is mantle cell lymphoma. When it is a 14-18, it is a follicular lymphoma. When it's an 8-14, it is a Burkitt's lymphoma. Very important, again, in lymphoma is to figure out whether it is a double hit lymphoma or it's a triple hit lymphoma. So double hit is usually with MYC rearrangement along with BCL2. And if there is a BCL6 involvement also, so 3 rearrangement, it's a triple hit lymphoma. So quickly everything can be detected. Right. So this is a case of hepatosplenic gamma delta T cell lymphoma, wherein there are classic cytogenetic abnormalities of chromosome 8 and 7. And here I would want to emphasize that there is an amplification of the 7q region. So this is a metaphase fish. And of course, you can see interphase fish in inversed duppy. And you can see the elongated 7 on the right-hand side top. And it is clearly indicative or confirmatory rather of this lymphoma. Coming to BLL, again, we have this entire set of biomarkers that we could do in by fish, and they are again individual markers which are prognostic, and it's important to detect them. I'm sorry, the slide is not moving, I think. Someone could help? No. Yeah, so this is a basic panel that we have of 922. Sorry, I'm not, again, repeating the genes because it's going to take more time. So the 922, the KMT2A, which is the 11Q or MLL, the 119 and 1221 in the pediatric cases, along with understanding the ploidy status, which we do by using centromeric probes for 4, 10, 17. And this becomes very essential because ploidy status is again a sole prognostic indicator of the disease, and we need to just check whether these are positive and negative. So ploidy, hypodiploidy or haploidy is pro-prognostic, and wherein you can get even hyperdiploidy, which we needs to report. There is an entity called endoreduplication here. This is just like a masked hypodiploid case wherein you would get some clones which are hypodiploid or haploid and some which are hyperdiploid or triploidy. And here this is important because we can clearly by cytogenetic or just numerical counting the metaphases, 100 of metaphases, and you can detect whether this is a masked hypodiploid clone or, and of course, even fish gives you some indication. This is an example of a hyperdiploid case, and what I want to show is this is a BCR-ABL positive, along with which there is a trisomy 4, which was detected by fish, followed by a really complex, not even complex, because it is hypodiploid. You can see all chromosome in triplicates. Another important entity is intrachromosomal amplification, and this we can detect of chromosome 21, which is IAMP21, and this we can detect by just using the 1221 probe. And here you can see there is too many red signals stacked one against each other here, all the interface, and this is a metaphase, which truly indicates that this is an amplification of the chromosome, of the gene on one particular chromosome. Yes. So I'll just skip some of these novel rearrangements. I just wanted to just tell you all that there are many processes that can be detected by cytogenetics. For example, this is chromothropsis, where you can see one chromosome has many other parts of chromosomes. So there is a rearrangement with, multiple chromosomes. Similarly, pH-like ALL can be detected by fish, by a good comprehensive fish panel. And of course, when it is negative, we can go in for a higher sensitivity and a higher good panel of RNA-seq and so forth. And important is to detect it because they can be well treated by TKIs and so on. So these are some of the, so here when PAX and ETV6 was rearranged by fish, it was also detected by conventional cytogenetics by 912 translocation. there is an episomal amplification, which is a recurrent abnormality in TLL. And here, these are some fusions that we could detect. These are episomes, so those will not be on the chromosomes. It will be in the cytoplasm. So this is important. The NUP 214-ABL1 is important to detect in TLL. And cytogenetics is well known. Again, its role in multiple myeloma cannot be, negated. And it's important to detect all the high risk markers. And so these are some of the high risk markers, which is TP53, 414, 1Q amplification, and some of the good markers as well. So let me just conclude by saying there are several advantages of cytogenetics. There are limitations, but one I should tell that limitations are fewer than the advantages, because it is economical. You can get your results in a shorter TAT, especially when you do FISH. It's a couple of few hours. The instruments that we require is very simple, right? Additional abnormalities can be identified. Clonal abnormalities, even if it is small number, can be picked up well. You look at the entire genome together. And there are some, of course, cryptic rearrangements could be missed out. You cannot detect mutations, and we require experience, technical staff. And sometimes there is no mitotic, proliferation. So that could be an issue. So the utility of cytogenetics in malignancies is tremendous, and we cannot do without cytogenetics. That I would like to conclude. And I thank my team and all my members and all my ATTRACT team, including the clinicians and the hematopathology laboratory. Thank you so much.